Okay, this is the Math 1401 Zoom meeting for Thursday, March 25th, 12 p.m. And we've got some questions from MyLab today. So can you give me the MyLab problem?
Yes, please. 1 minute, please.
All right. This week, we're working on word problems. I did 37 Monday night. And we're going over through 45. 45 is a big, long problem about basketball point spreads. Those are the forwards word problems, and then the backwards word problems from 47 through 51 on the next, 51's on the next page. A repeat, 47, 49 are repeat. 47 is a repeat of 37, 49 is a repeat of 39. We can't see that too well on the Zoom, but have you got your problem?
Yes, please. 37, 2.2.37.
7.2.37.
Yes, please.
What does it say?
Okay.
Is it about eggs?
Okay. It says the mean. It says the mean incubation time for a type of fertilized egg. And the mean incubation time for a type of fertilized egg kept at a certain temperature is 24 days. Suppose that the incubation times are approximately normally distributed with a standard deviation of 1 day. Complete part A through E. So part A, we have like, you have to choose the graph.
All right. With just this information,
Yes, please.
you should choose a graph. It looks like this with mean is 24 days in the middle.
Yes, please. Then they say the normal standard deviation is 1 day.
Right. You can, I don't know if they have it labeled on the graph or what, but you can write it again. With just this information, they haven't given you any numbers to shade around. So this is all you can draw.
Yes, please.
Yeah, this follows 37 in the book. In the book, the mean was 21 days.
Okay.
So they're tracking 37. Same standard deviation in both problems, though, standard deviation of 1 day. Did you want to see any of the other parts?
Yes, please.
What is part
So
B?
is it how the graph's supposed to look?
Yeah.
Okay, thank you.
Yeah, I don't see any other way to draw it. Yeah, it should look basically like this. What does part B say?
Okay. But the graphs that I'm seeing here are like different. Like the first graph is in between. 24 is in the middle. And then we have 2 lines between 23 and 25.
Okay.
Then the second graph, 24 is in the middle. Then you have another line between 22 and 26.
Have they given you those numbers up here in the paragraph?
No, what I have here is the table, the standard deviation table.
Okay.
The standard deviation distribution table, like the normal table that we have.
Right.
So the graph I'm seeing here, like this one, 27 is in the middle. So this one is wrong.
Yeah.
I think the one with the first one is 24 is in the middle. Then in between you have 23 and 25.
Right.
Then the second one, you have 24 in the middle. Then you have 22 and 26. I think the first one should be right.
Okay, yeah, I don't know where they're getting those numbers if they haven't set them here, but yeah. Pick it and see if it's right.
Okay, let me try.
You have another participant. Is that Mr. Augustine? I don't see your name on the screen.
Yeah,
No,
that one is right.
No, it's Lisa Wisby. How are you?
Ms. Wisby, how you do? Now I see your name. Have you got any questions?
I'm watching. I have 12 more to do the work. I have all the work problems to do, so I'm just observing.
Okay. Well, this one comes from my lab. Ms. Obase is asking about it, and it's tracking the problem 37 here. It's just they've changed the mean number from 21 to 24.
Okay.
Got the same standard deviation. I'm waiting for her to give me part B.
Okay, part B says find and interpret the probability that a randomly selected fertilized egg hatches in less than 23 days.
23 days.
Yes, please.
Okay, let me go to the next page, give myself a little more space. Can y'all see my writing in the screen pretty good?
Yes, please.
Okay. So the picture of this would go, I'm only going to draw the one picture for these numbers. 24 in the middle, that's your mean. 23 is less than 24, and less than 23 would shade to the left. This would be hatching in less than 23 days. Questions so far?
Yes, but the questions say you should find the probability.
Right. So we need a Z number.
Yes, please.
Z score, they call it. Z score or Z number. And that Z will be 23 minus 24. That's your X minus mean, divided by your standard deviation equals 1, which means 23 minus 24 over 1. Can you tell that's -1?
Yes, please.
And again, you could do that in your head. They kept the numbers easy. Your standard deviation is 1. So if you're at 23, you're 1 standard deviation below your mean here. Which means I need to tack on 2 zeros. Split off that 0. Grab my table. I need -1.0. Hold it up, see if you can see negative. There's -1.0. And 0, 0 column.
Yes. 0.1587.
87. Actually got the same answer as the one in the book. Yeah. That would be the probability or area to the left of the black. And that's my answer. Probability of being less than 23 days would be equal to 0.15. 7. That's a straight table lookup trick
Okay.
that we showed last week. If they'd asked greater than 23, then I'd have looked it up, gotten this, but subtracted it from 1. Do you want to see any more parts?
Yes, please.
Which next part, C?
Okay. Part C says no. We are still on part B.
Still part B?
Yeah. It says interpret this probability. Select the correct choice below and fill in the answer box to complete your choice. So here they said if 100 fertilized eggs were randomly selected, dash of them would be expected to hatch in less than 23 days.
Okay, this isn't in the book. So you've got 100 eggs. What percent would hatch less than 23 days?
Yes, please. This is like to choose. It's like for us to choose because it's A, B, C. It's like for us to choose the right answer between A, B, C.
Sure thing. Well, I'm going to give you my answer written down here and see if you can match it to something they had. So the percent is 0.1587. So you see, that's the percent that'll last in 23 days. So out of 100 eggs, you need this percentage of the 100 eggs. So the number of eggs would be 0.1587 times 100, which works out 15.87. Now, you don't really have 0.87 of an egg, so I don't see your screen, so you're going to have to, do they have an option of 15 or an option of 16?
Okay.
Can you see either one of those? Do they?
No, actually there is a dash on the place. There is a place that you need to put the answer because they say you should round it to the nearest integer as needed.
All right, if you round to the nearest integer, that would give you 16.
Okay.
To nearest integer. So I'd give you full credit for either one, you know, on the test myself.
Okay, part
Yeah,
C.
I'm
Part
sorry.
C say find and interpret the probability
I
sorry.
think Miss Wisby was trying to say something. Miss Wisby, you got something
Okay.
to say?
I was gonna say that's very gracious of you. Unfortunately, in Stat Lab, you get, if you don't have it exactly right, if you leave off a 0, whatever, they mark it wrong. But thank you for being so gracious.
No, you don't have to thank me all at once. Yeah, that's the thing about these dumb computers. You gotta fight the way they programmed them.
Right.
They programmed them to accept certain answers. That's one weakness of them.
Yeah.
Computers do not do nuance.
Oh, they do not.
No, they don't, unfortunately. All right, you ready to try part C?
Yes, please.
All right. Go ahead.
But C says find and interpret the probability that a randomly selected fertilized egg takes over 25 days to hatch.
Okay. 5 days. You could shorten that up, say probably greater than 25 days. We draw a picture. Mean is 24. Standard deviation is 1. Can you tell at 25 you're going to be 1 standard deviation? But I'll do the formula. You'd have 25 minus 24 divided by 1. This is your x, this is your mean. You're dividing by your standard deviation. That's going to be 1. Why did I write negative? That's going to be 1. I need to add again 0.00.
Okay. Then do we have to look it up?
Forwards, which splits off that 0. I grab the table. 1.0 is right there. And the 0 column. 0.8413, but you know that's not the answer, right?
Yes, please.
That is the area of the black.
Yes, please.
So this is a right side trick problem. You see what I got to do to get the answer? I've got to subtract this from
1.
The right side trick. The probability would be 1 minus 0.8413. Yeah, I bet that's 0.1587. Isn't that amazing? How can that be? 1 minus 0.158, I'm sorry. It's 1 minus 0.8413. 1 minus 0.8413 is 0.1587. Isn't that amazing? That's the same answer we got last part. How can that be?
It's because the first part was negative 1, and this one is also negative 1.
Yeah,
so I guess that's why.
That is exactly why. And I thought
Answers are the same.
can't really get them on the same screen, I guess, without covering one up. But yeah, this is at 1 z equal 1 standard deviation. So you got that area 0.1587 there. And sure enough, back in part B, we're at z equal -1. So it works out symmetric with the same probability, either side of 1.
Okay.
Okay.
Still on the part C. Part C say interpret this probability. Select the correct choice below and fill in the answer box to complete your choice.
Okay.
A, if 100 fertilized eggs were randomly selected, dash of them will be expected to take more than 25 days to hatch. Round to the nearest integer as needed.
All right. You're actually going to get the exact same answer as
The
part
exact same answer.
because it's the same percentage and it's the same number of eggs here. So yeah, your number of eggs will be 1.1587 times 100, 15.87 when they round, going to be 16 eggs.
Wow.
Yeah, you're just on the right side of the normal curve, but you got the exact same percentage and they asked about the exact same number of eggs. Do these go in the category, they look so easy when I do it?
Yes, please.
I get that complaint a lot. It looks so easy when he does it.
Then
Yep.
D says find and interpret the probability that a randomly selected fertilized egg hatches between 22 and 24 days.
22 to 24.
Yes, please.
All righty. So remember, the mean was 24.
Yes, please.
22 is this side. So 22 to 24 is this sliver right here. We need the Z number for 22. Find Z to be 22 minus 24 divided by 1. You'll be able to tell that's -2. It's going to be 2 standard deviations lower than 24.
Okay.
Back on the 0.00. -2, remember, split off that 0. -2.0. 0 column is 0228. Read that. That is this direction. You don't really have to look up 24. You should remember that it's 0.5 each side of that center. If you did want to look it up, you'd have 24 minus 24 divided by 1. That's 0. You can actually look this up. Believe it or not, you can look this up. You would look up
0.0.
Yeah, you can either look it up from this bottom here. It actually says -0, or you can look it up from the top corner. Yeah, 0.0 and the 0 column, and you see what you got?
0.5000.
Yeah, 0.5, which is, again, on the left side, all the way.
Yes, please.
So you see how to get your answer? This is contained inside the 0.5. You would simply subtract them, right?
Yes, please.
Equals 0.5 minus 0.0228. 0.5 minus 0.0228, 4772. Do they do the same thing and ask you about 100 eggs again, or?
Let me check, please. Yes. The set now is interpret this probability. Select the correct choice below and fill in the answer box to complete your answer. The average proportion. A says the average proportion of the weight to hatching of all eggs fertilized between 22 and 24 days is dash. Round to 2 decimal places as needed. Then B says in every group of 100 fertilized eggs, dash eggs will hatch between 22 and 24 days.
Okay.
Round to the nearest integral as needed.
Okay.
C says if 100 fertilized eggs were randomly selected, dash of them would be expected to hatch between 22 and 24 days. Round to the nearest integral as needed.
Okay, I'm not quite, yeah, tough to remember all 3 parts. I'm not quite getting the difference between B and C. And I've forgotten what A was. Okay, can you go back to A? A asked you to round this to 2 places. That's what I got out of it.
Yes, A says it's still in part D. We are still on part D.
Right.
So part D says, the part below says, you should interpret this probability, select the correct choice below and fill in the answer box to complete your choice. So A says the average proportion of the weight to hatching of all eggs fertilized between 22 and 24 days is, they say you should round to 2 decimal places as needed.
Right. So
B says,
okay, don't charge it to B.
okay.
Let's finish A.
Okay.
So basically we're rounding the 0.4772 to 2 places.
Yes, but you know we have to just select one answer from A, B, C. That's correct. We are not doing all, but we have to select just one from it because that's the choice that they have given.
Okay, not quite getting that, but the rounding this to two places gives you this. Let's get the answers to them all, and then you can see which one you can pick.
Okay.
Now, B, I got 100 eggs, and they wanted the number of eggs.
Yes, please.
Are they using the 4772 or the 48? Doesn't really matter.
Yeah.
772 times 100, that'll give you 47.72. And if you round, you're getting your 48 eggs, as if you multiplied this by 100. 48 eggs. And I'm not quite sure what C said. I didn't get the difference between B.
Okay. That was A, right? Or that was a B?
That was
C says if 100, but C says if 100 fertilized eggs were randomly selected, dash of them will be expected to hatch between 22 and 24 days, round to the nearest integer as needed.
I don't know. What I hear you say, it sounds identical to B. It'd still be 48 eggs.
Then B says in every group of 100 fertilized eggs, dash X will hatch between 22 and 24 days, round to the nearest integer as needed.
Yeah, I don't get the difference.
That's it. But from my own thinking, I think part C should be the answer, the right one, following what we did with the first one we got. Yeah. If it follows the same system, I think part C should be the answer.
Okay, go ahead and try it.
Yeah, let me try. So 48, right? Yeah, part C is the correct answer.
Okay.
Part E. Part E say, will it be unusual for an egg to hatch in less than 21 days?
Okay.
Why? So they come down and they say the probability of an egg hatching in less than 21 days is dash. So it's dash. Be unusual since the probability is dash than 0.05.
Right, that's the criteria for unusual, probability less than 0.05. All right, so we've got to find that probability of hatching in less than 21 days.
Yes, please.
21 days, hatching less than that, 24 is in the middle. Can you tell that's going to be 3 standard deviations, -3? Your Z number is going to be 21 minus 24 divided by 1, which is -3. I'll stick on 2 zeros. Split off that 0. -3 is right here. 0, 0 is 0.013. So from the table, equals 0.0013, which is this direction. Clearly less than 0.05.
Okay.
Unusual? Yes. 0.0013 is less than 0.05. I'll leave it to you to figure out how to enter it into the computer.
So the answer will be 0.0013, right?
Is your probability of hatching less than 21 days? Yes.
Okay. And then it means the selection here will be it means I'll select would not right? Would be unusual, right?
Yes, it would be unusual.
Okay. And then it is less than 0.05.
Right. All right, are there any other problems? Ms. Wisby, you got any problems you'd like to see?
No, I'm just observing and taking notes. Thank you, my classmate, for asking these questions because I know I'm gonna get stumped in stat lab. I know I am.
All they do, the other problems is just change this mean and then the numbers they ask about.
Okay.
Yeah,
What
that's
about
simple for you, but
Yeah, I understand.
okay, what about part 4 of this same 7.2? Like problem 7.2.47. Can we try one of the problems?
Okay, what does it say?
Okay. What's it say?
I have a question while she's preparing for you for the question.
Go ahead.
As far as the test goes, it's only going to be 7.2, but it's going to be all of 7.2 word problems and all the video from last week. Okay.
But it's also got 6-1 on it.
Oh my goodness. Okay.
Okay.
Okay. Thank you.
Uh-huh.
When is the exam? Is it this week?
It is this week. We finished 7-2. It's this week. It's tomorrow.
Friday?
Yeah, he'll post it tomorrow.
Yes, we will post it tomorrow. It's
Okay.
due Sunday, but turn it in whenever you can get it.
Okay, thank you so much.
Probably have a deadline, absolute deadline of next Wednesday night again.
Okay, thank you.
Will it be the normal 20?
Yes.
Okay.
Okay, part 7.2.47. It says the mean incubation time of fertilized eggs is 21 days. Suppose the incubation time are approximately normally distributed with a standard deviation of 1 day. A, determine the 11th percentile for incubation times.
I heard 11th percentile.
Percentile for incubation times. B, determine the incubation times that make up the middle 97%.
Okay. Okay. Do you recognize this? These are backwards problems.
Yes, please.
This is 11% to the left. So on your curve, you got 21 for a mean, I heard. Standard deviation equal 1. So you're going to have some point over here in X that will have 11% to its left. Don't forget there's 0.5 to each side. Okay, I've got no direct way of getting from this to that X, but I can get from this to a Z.
Yes, please.
So I look up 0.1100 inside the table. All right, I'm seeing a 119, 1170, 1151. I'm working my way back to 0.11. Oops, I don't know if y'all can see this. 1131, 1112. Wow, there we are. I've crossed 0.11. There, that's lower than 0.11. There's my two numbers. I'm going to write them in least to greatest order. 0.1093, 0.1112. Do I need to show them again? There they are. They're the closest numbers to 0.11. This one's 12 bigger. That's about 7 smaller.
Yeah.
This is 7 smaller, 12 bigger than 0.11. All right, so I'm going to pick this, being the closest, giving me a Z of negative 1.2. See the row there, if I get the row on. Negative 1.2, yeah, you can barely see the column. I'm in the O3 column. Negative 1.23.
Okay.
23, sorry, 23. 23. So I know that that X is 1.23 standard deviations from 21.
Okay.
Now you go to your forwards equation, minus mean, divided by your standard deviation, and you stick in negative 1.23 for the Z. Your X is what you're trying to find.
Yes, please.
X minus 21 divided by 1. Now, with anything other than 1, I'd have to literally multiply.
Yes, please.
But, you know, with the one is so simple, you don't. But most of the time, you got to multiply by that number, so I'll at least show it. But that doesn't change the negative 1.23. So then on this one, I've got to add the mean, add 21. Well, I got to go X minus 21 is negative 1.23. I'm going to add 21, add 21. I'll run out of paper. Negative 1.23 and add 21.
Okay.
Or 21 minus 1.23, either way. Negative 1.23 and add 21. Y'all see that? 19.77. You can barely squeeze it on. 19.77. Answer. That is the number of days where you got 11% of the eggs hatching less than that. That would be called the 11th percentile. Not 11%, percentile. I don't know if I can squeeze it on.
Okay, they say round up to the nearest whole number. It means it's supposed to be 20, right?
Right, so round to the nearest whole number and you'd be at 20 days, yes. Got a little small there, squeezing that on. Yeah, rounded to the nearest whole number would be 20 days.
Yes, please.
If you want to see part B, middle 97%.
Yes, please.
Okay. Part B says middle 97%.
Yes, please. There will be 0.97.
Okay. So there, again, 21 in the middle, standard deviation is 1. There's an X over here and an X over here that would have 0.97 in the middle. So I've got to find this percentage. Shade it. Can you tell it's 0.015, I think? 1 minus 0.97 is 0.03. There's 3% on each side. So if I divide that by 2, I think you're going to get 0.015. I'll divide it by 2 just to make sure I don't have the decimals messed up. .03 divided by 2. 0.015. In effect, 1.5% here, 1.5% here is your 3%, add 97%, you're at 100%. Questions so far?
Yes, please.
So I'm going to come down here. I'm going to find my Z. So I look up 0.015 backwards. Got an 0.158. I'll read that. 0.154. Oh, it's there. It's a mirror. That's I didn't realize it'd be there exactly. It's there exactly. 0.150. See that?
Yes, please.
Yeah, giving you negative 2.1. 07 column. If I can come over, it's negative. So wide I can't get it on, but it's in the negative 2.1 column. I'm sorry, negative 2.1 row and the 07 column. Negative 2.17. All right, another one you didn't have to bracket. All right, we've got to find both x's. You want to call this number 1 and the x number 2. Don't forget, by the way, it was the z of negative 2.17 goes for this x, and what would be the z for this x?
2.7.
2.17, right?
2.17, sorry.
2.7, right. So you just got to plug into those forwards equations again. Z equals x minus mean divided by standard deviation. Negative 2.17 equals x minus 21 divided by 1. I'm just going to add 21 just to speed this up. Add 21, add 21. Because I can ignore the divide by 1. So that's going to be 21 minus 2.17. $18.83. If they wanted to the nearest integer, then that would be 19.
Okay.
And then I do the same thing for positive 2.17. 2.17 equals x minus 21 divided by 1. I'm going to add 21, add 21. You can do this in your head. You would get 23.17. If you round, x equals 23.
So the answer is negative.
Well, the answer is 19 to 23.
Okay, one won't be like negative 19.
No, it's not negative 19.
Okay.
Yeah. See, this is 21 days to hatch an egg. So
Yes, please.
that's time. So time can't be negative.
Okay.
So don't get confused between the negative z versus your actual answer.
Okay, thank you.
Yeah, the negative z means you're below 21, but that answer is you're this far below 21, but that's still positive.
Okay.
Okay, questions about this? Any others? Oh, we're at almost 50 minutes. Time is flying by.
Yes, please.
We're gonna meet again at 8 o'clock. If anybody wants to come out, we'll have another Zoom meeting at 8 o'clock tonight.
I don't think you send the link.
The what now?
I don't think there is a link for 8 o'clock.
Yes, it is. It's there.
Oh,
There
it's-
is.
Yeah, it's dated 3/21
Okay.
at 9:36. Yes.
yeah.
Okay.
If you can't find it, let me know. Send me an email. I'll be happy to send it out again.
Okay. Thank you.
Yeah, I'm trying to send them out all at once so they're in one spot for people.
Yeah. And I just want to thank Obeys for her tip in Stat Lab a couple of weeks ago about question help. I had been doing those questions and I never even paid attention to that drop down. And that's helped me to see how problems are worked.
Oh, good.
So I just want to thank her for that because I don't know how I missed it, but I did.
Those
Thank you so
programs
much.
have so many options. Yeah,
Yeah.
they drive me nuts too.
Yeah.
But yeah, I'm glad you found that helpful. Very good.
Yeah, I did.
Well, we seem to be really focused on eggs today. Does anybody want any other parts, or do you want to save them for tonight? Or any other questions?
I think I will go ahead to try and do the questions as much as possible. Anyone I find difficult with, I'll probably bring it in the next section.
Okay.
Thank you so much.
All right. Sure thing.
Yeah, me too. I'm gonna work them and if I have any questions, I'll come back tonight.
Sounds good.
Okay.
We'll be here at 8 o'clock. Thank you.
Thank you.
Thank you. Have a wonderful
Bye.
day.
You too.
Thanks. Same to you. Y'all have a good afternoon.
Bye, Lisa.
Bye-bye.
Bye.